started like any regular night at work. A small glimmer showed up during a wide field scan in addition to a star map we knew well. At first it seemed like just another short-lived thing we'd note and then forget. A speck traveling alone through space. But right away this little visitor started acting unlike anything we'd ever seen. What Skywatchers first thought was a new object from another star system would soon make scientists and everyone else rethink what it means to have the universe watching us. On July 1, 2025, a team scanning the skies saw something moving through our inner solar system. It got the name 3I, the third interstellar object we found, but that name didn't show how much it would mess with what we expected. At first it looked normal, small, bright, with a fuzzy glow and a tail like a regular comet. But as we pointed telescopes at it, using our usual tools for studying planets, things didn't make sense. Comet tails should point away from the sun. Sunlight pushes tiny particles, sending dust and gas outward in a clear way. The tail always follows behind, like a streamer behind someone swimming. But Atlas's tail did the opposite. It pointed toward the sun. No matter where we looked from different places and with different tools, it always showed a narrow stream going toward the sun. It wasn't a wide, fan-shaped glow. It was a focused, steady arc aimed at the star. It was confusing and wouldn't go away. People started wondering if there were problems with how we were seeing it, or if there was something wrong with the data or the cameras. But those ideas didn't hold up. The Gemini South Telescope in Chile, the Lick Observatory, and space telescopes all showed the same strange thing. The chemistry made things even harder to understand. The best tools we had showed a chemical makeup that was very different from normal comets. Water vapor, which is common in our comets, wasn't the main thing here. Instead, carbon dioxide was in amounts we almost never see. There was way more CO2 than water. Very different from what we expect. Plus, there was a lot of nickel and almost no iron. A weird mix of elements that didn't match any comet we knew. This looked like it came from somewhere else where things freeze and trap elements in different ways. Besides the chemistry, the way it moved was also odd. As experts looked at its position and worked out its path, they found small differences between where it should have been and where it actually was. Ones that gravity couldn't explain. When they changed the math, they saw a tiny push toward the sun. Everything made sense then. It was a small amount, but over time it added up to big changes. It was like the gentle push from the engines we use on spacecraft. What made it strange was that push along with a stream that looked like an exhaust. It was narrow, steady, and focused. Not like the messy cloud of dust we see from melting ice. Scientists started comparing it to something else. If something wanted to slow down as it came into the inner solar system, shooting a stream toward the sun would make sense. It's the best way to lose speed when you're moving fast. That's what we do with our spacecraft. Atlas seemed to be doing the same thing. The shape of the stream, the direction of the push, the hints of charged particles all suggested it was made to do that, or at least acting like it was. This wasn't just another strange object. The path it took was also surprising. A path that went the wrong way and cut through the plane of our solar system, coming close to several planets. The chances of a random object from another star system hitting a path that goes near Mars, Venus, and Jupiter seemed very low. It looked like a planned route made to use the gravity of the planets. Something using gravity like that suggested a purpose, something beyond just chance. And then there was the timing. Atlas was going to pass behind the sun on October 30th, 2025. When that happens, we can't see things directly because of the sun's glare and radio noise. It's a good time to make a move without being seen. If something wanted to change course without us knowing, going behind the sun and firing its engines would be perfect. Just the fact that it might have engines and was about to go behind the sun raised alarms for people who watch for threats to our planets. When the James Webb telescope and others looked at it closely, they saw things that looked like engines, not just melting ice. The stream had particles moving at similar speeds like the exhaust we see from engines. They didn't see xenon, which we use in our engines, but the stuff they did see could be charged and sped up to make a focus stream. How the stream was spread out and how fast it was moving didn't fit with just melting ice. It was controlled and steady. Given all that, some scientist had a wild idea. Maybe Atlas was a probe. Not an alien spaceship trying to talk to us, but a robot scout that any civilization might use. A sensor to go into other star systems, take measurements, and change course as needed. If you imagine a network of these things drifting through the galaxy, then Atlas could be one of them. Part of a pattern we're just starting to see. That idea got a lot of attention when people at JPL and other places did something unusual. They compared Atlas's path with those of the other two interstellar objects we'd found. Each of those had been strange in its own way. Amwama had a push that couldn't be explained and a weird shape. Boris had comet-like chemistry, but came from outside our system. But when they looked at them together with Atlas, a pattern started to emerge. The paths seemed to echo each other with similar alignments and routes that seemed planned. This technique, called orbital fingerprinting, looked for connections and repeated things that might show a design or a pattern. When they fixed the paths to account for how we see things, the arcs lined up in ways that seemed too good to be random. Some scientists started quietly talking about a repeating pattern, probes launched in a sequence, visiting systems on a schedule too exact to be just chance. But not everyone agreed. Science is all about questioning things, and for every paper that suggested a design, there were others trying to explain it with natural reasons. One idea was that Atlas wasn't made, but was the remains of a big event in another system. Imagine planets colliding or a star exploding, throwing stuff into space where only the strangest things survive. In this idea, the carbon dioxide and nickel come from forming in very cold places and from broken metal objects. The stream toward the sun could be from weird melting under intense sunlight, something we haven't seen because we don't have samples from those conditions. That keeps it natural, but it means we have to imagine strange chemicals and structures we don't know about. There's also the question of problems with our instruments. At the same time they were studying the stream, several telescopes reported glitches, lost signals, and short stops in data that happened when they were pointed at Atlas. These were small, repeated, and only happened in certain parts of the spectrum, the same ones we use for talking to spacecraft. Some teams saw more background noise, others saw delays in data, and a few saw strange readings in their instruments. They weren't big problems. The instruments worked fine when looking at other things. The pattern raised uncomfortable questions. Was Atlas messing with our instruments on purpose or just testing them? If something was made to sense technology, to find instruments and to test our reactions, those small signals might be how it does it. Think of it not as sending a message, but as scanning for signs of observation. How we point our telescopes, what signals we use, how fast we react. The glitches could be a way to see how much we notice it, not to communicate, but to map if our system can notice and understand strange things. People were also getting worried because we're getting better at seeing things. The Vera Rubin Observatory was starting up, and its ability to see deep, wide, and fast meant we'd find way more interstellar objects, from one every 10 years to many every year. More eyes and smarter software meant we were finding things previous generations would have missed. That should be good news. But with Atlas and other strange things, it also meant we might be seeing just the start of something bigger. Small oddities that, when put together, show a pattern of activity crossing our solar neighborhood. When you start connecting the dots, it's hard to stay surprised. Some scientists started imagining scenarios that included multiple interstellar objects in a connected web. Paths that seemed random at first turned into tracks that went through our solar system, with a precision you could only see with lots of data over a long time. Instead of separate objects, these could be parts of something bigger. A network of observation points left by beings whose timescales are longer than human ones. If that's true, it's huge. We're not alone, and we're being watched by things that seem intentionally placed. Of course, that's a big claim, and big claims need big proof. The science group reacted by checking the analyses, asking for more data, and demanding that everyone share what they saw. They ran simulations on supercomputers for weeks, using models that included thrust and particle emissions. The results were strange. Only when they let the models include purposeful emissions did the data match. When they insisted on randomness, the data didn't fit. It's worrying when nature doesn't agree with the simplest models and the next most likely thing is purpose. The story got out and headlines used words that went between awe and fear. People talked about the chances of alien probes. Online forums exploded with ideas about covering moons with reflective material and sending messages to the sky. NASA and ESA were careful in their statements, saying they were unsure and cautious. But underneath calm bureaucratic words, a new worry started among policymakers, ethicists, and even defense people. If things are surveying star systems on purpose, what should we do? Does watching us mean we should react? Should we try to change the path of an interstellar object? Who gets to decide? There's a long history of protocols in the science community about meeting alien intelligence. There are protocols, frameworks, and groups to advise governments on first contact. But Atlas isn't a message. It's a physical thing that reads like a question. How should we react to a probe that watches but doesn't speak? The discussion quickly split between those who wanted to wait and see, and those who wanted to plan for anything. There were also practical things to worry about. If something moves in ways we can't see when it's behind the sun, could it change course to threaten planets or satellites? The chances of it hitting us are very small, but the fact that it could make a move without us seeing it raised concerns about surprise attacks and keeping our planet safe. Agencies reacted by improving their blackout protocols, using radio from spacecraft in other parts of the solar system, and working together to watch. During the key period, then there was the human side. Scientists found themselves in the middle of a big event. Emails became encrypted. Data flowed between places, and orbital reconstruction was suddenly popular. There was excitement and fear. Young scientists were thrilled to be part of something big, while older ones urged caution. The tension between wonder and discipline became part of the story. As October 30th came and Atlas went behind the sun, people could only watch history being made in reverse. Instruments switched to protocols for when they lost visual contact. Teams prepared for long gaps in data, and simulations prepared for anything that could happen. The question was simple. What would happen behind the sun? Could be nothing, or it could be something big, a new path that we'd only see when it came out. When Atlas reappeared, everyone held their breath. Eyes scanned the arcs, instruments took pictures, and algorithms compared new positions to old ones. The world waited. What came out was both boring and eye-opening. Some things had shifted slightly. The biggest change was a slight change in direction, as if it had made a small course correction. It wasn't enough to cause alarm, but it meant that the decision to wait and see had consequences. There were ideas about what it meant. Some said it was proof of engines. Others said it was within what could be explained by melting ice. What was clear was that we were still watching and arguing. More things were found in the months that followed, some strange, some normal. One seemed to have no glow at all. A cold, dark object coming from deep space. For the first time, we had enough interstellar objects to start making sense of things. As we looked back, the event made us think differently. We built telescopes to see out, but we hadn't prepared to be watched. The galaxy looked busier and possibly more intentional. Planned or not, it changed the way we thought about planning, safety, and the ethics of curiosity that goes beyond just the science. If probes are roaming to observe and timing their appearances to when they think we're watching, then we've crossed a line. Seeing them isn't just a technical thing, it's a cultural one. Our telescopes aren't just instruments. They're triggers for things we can't fully see. We have to ask hard questions about how we react to things that might be watching us. Even if we find out that Atlas is just a natural object, that would still be huge. Finding a new kind of object with that chemistry would rewrite our models and help us understand the galaxy better. The universe is weirder than we imagine. If Atlas is a probe, then we face different questions. Why are they here? Are they from a civilization long gone? Are they part of a program? Are they harmless, or are they testing us? Answering these would be hard for both science and diplomacy. For now, the best thing is to keep looking, improve our instruments, work together, and build rules for how to react to strange things. The coming years will be exciting and scary. Rubin and other telescopes will give us data, and we'll use AI to find anomalies. We'll compare observations, and ethicists and scientists will think about how to handle being watched. Atlas was like a mirror showing us how we handle surprise, how we deal with data, and how we balance curiosity with caution. It reminded us that technology brings visibility, and that invites it to response. Whether Atlas is natural or made, it started a new conversation about our place. As more eyes sweep the heavens, more anomalies will be found. Each new object will test us. Whether these become a web of watchers or just new things, the result will be a richer picture of the galaxy and our place in it. In the end, Atlas isn't a message. It's an invitation to look harder and that we are also being watched. That changes how we design, how we write policy, and how we think about our planet. The cosmos has always been big. Atlas suggests that may be more going on than we